This is the setup video for the Wave Optics lab. So in this lab, you're going to look at a double slit. All right, so basically what a double slit is on this slide. You'll see there's actually 3 single slits on one side and 1 double slit on the other side. Okay, and what you're going to do in this lab is you're going to measure the distance between those 2 slits. All right, so one way to do that is with calipers, but you're not going to get too accurate of a measurement doing it that way. So what we're going to do is we're going to use interference to determine the distance between those 2 slits. So you either got a slide with the double slit in it already in this holder, or you got a slide and one of these holders. All right, so the only difference is this one, if it's falling off, you might just have to tape it on there into place. Okay, so I'm going to set up the double slits in front of the laser pointer. So for the laser pointer, you either got a silver one that looks like this, and it produces a red light, or you got a black one like this that produces a green light. Okay, you also have in your kit a tripod holder for the laser pointer. So basically you're just going to snap the laser pointer into place and place that in front or behind your slit. All right, so the silver one will turn on and stay on. All right, but the black one, you're going to have to put a piece of tape over the button to hold it down while you're working. Okay, and then finally we have a screen over here. So what I did is just taped a piece of white paper to this box. All right, and then we'll get our interference pattern. So your pattern looks something like this, and it's going to be a lot easier to see if you turn the lights off. All right, and it'll also be easier to read if your screen is further away from the slits as you can get it. All right, and so what you'll notice in the middle here, there's this bright spot. All right, that's called the central maxima. So in the instructions document, there is a figure in there that shows you what all the parts of the pattern are going to be. All right, and then you see all these other bright spots to the side of it. Then you're going to use the calipers, and you're going to measure the distance from the central maxima out to about the 10th one, or as many as you can get. And then you're going to divide by 10, or however many you counted, so that gets you the average spacing between the bright spots, and that will be your delta Y. All right, the other measurement you're going to need to take is what's the distance between your screen, all right, and your double slit. So I gave you a tape measure so you can measure that distance, right? And the last thing you'll need to know, which is also in the document, is the wavelength of your laser light. So the green laser light has a wavelength of 532 nanometers, and the red one has a wavelength of 650 nanometers. And that is the setup for part 1. In part 2, you're going to use thin film interference to measure the thickness of one of your hairs. So to do this, you're going to need 2 microscope slides, which came in a package like this. You also need a rubber band, and I give you some gloves so that you don't get any fingerprints on the microscope slides, which will make it difficult to read the fringes you're going to look for. Right, so you're going to take the 2 microscope slides, place a piece of your hair in between them at one end, and then you're going to tie the other end tightly with one of the rubber bands. Okay, then what else you will need is you will need the red filter, which came in the manila folder in your kit, and you'll also need a fluorescent light. So you can find one of these in lots of places like classrooms or public library maybe. Or you might have one at home in your laundry room or basement, or you might have a compact fluorescent light bulb like this, okay? And they will work just fine. So fluorescent lights have mercury in them, And so that's what's going to enable us to see the interference pattern of the air in between the microscope slides. So on a white piece of paper, you're going to want to mark out a 1 centimeter area, and then you're going to place the microscope slides over like that, over that area, because that's going to be the easiest places to see the fringes. All right, so we'll turn the light bulb on, and know that fluorescent light bulbs take a minute or so to warm up. So if you don't see anything right away, just give it a minute or so for the light bulb to warm up fully. All right, then you're going to take the red filter and you're going to put it in between the light bulb and the microscope slide. All right, and now you should be able to see some bright and dark fringes, or basically alternating lines on the microscope slide. So you won't be able to see it in the video camera here probably, but there should be about maybe 20 to 60 lines in that 1 centimeter area. All right, and that is the setup for part 2.